Question number 1. Right, an aircraft is flying due south. At 1000 hours, point P bears 267 degrees from the aircraft. At 10 hours 6 minutes, point P bears 275 degrees true from the aircraft. If the aircraft has a ground speed of 120 knots, estimate the range of the aircraft from point P. You will encounter similar kind of questions in your radio nav as well, but there we probably would tell you a different way of actually doing the same type of question. But let's look at this question here. Question number 1. Yes. What does it say? The aircraft is flying due south. Okay, which means it is having it's flying a track. It's a true track given here. So what's the track of the aircraft? Due south means
it's 180 degrees.
Yeah, not significant. The number 180 is not significant, but just to give an idea. True due north means you're flying along those true meridians down south. At 10 o'clock, point P bears 267 degrees from the aircraft. Now what is that? So it's from the aircraft. So P from the aircraft. How much is it?
It's 267 degrees true.
At
10 hours.
10 hours, 10 o'clock, right? What's the meaning of this? Point P is from where? Always, as you see in the convergency also, make sure you focus on from point. It's from the aircraft, right? So let's keep the aircraft somewhere here. This is the aircraft point. And from the aircraft, we're talking about true values here. So basically we have the true meridian, which is here, true north, right? And whereas point P is 267 degrees from the aircraft. From true north, you have to now measure 267 degrees all the way, and then you have to mark the point P. So point P is somewhere here on a bearing of 267 degrees true from the aircraft. Is that clear?
Yes.
Right? Now the point P, the aircraft is right here. The aircraft is here.
Yeah.
Let me run up these true north and stuff now because I don't want to the lines coming out here. The aircraft is now, it's moving. It's moving at what's the ground speed of the aircraft? Ground speed of the aircraft?
It's 120 knot.
120 nautical miles, the ground speed. That ground speed it is moving, and at what time? At 10:06 hours. Where is point P from the aircraft now?
It's at 275 degrees true.
275 degrees true. See, do you understand that this bearing is actually going to increase as the aircraft is traveling down? Now you see, the aircraft is traveling all the way down. At one particular point of time, you can see here, what is the bearing of the point P from the aircraft, and it's actually a beam the aircraft?
270.
270, it's 270 right here, right?
Yeah.
Which means if I look at the right wing, I can see point P, right? The aircraft is moving like this, right wing of the aircraft, and I can see point P, a beam the station P. The aircraft keeps on moving until it is having the point P is at a bearing of 275 degrees, which means it crosses this all the way and reaches somewhere around here. So you see the bearing, this is a bearing of 3 degrees, 267 to 270. Now another 5 degrees means we're going to go a bit more forward here. Right? And now the aircraft is here, and now you can see again from the true north, you measure 275 and
75 degrees
towards speed.
Yeah.
75
degrees.
True. Make sense? Now you're asked to find out.
Yes.
What's the question? You're asked. I'm just rubbing this line off just to show you that we are crossing that a beam point and we are moving further forward. If it's a beam, it's either 270. If point P was here, it's going to be 090. But it's going to be either of those, right? Since you're moving 180. All right. Now, what time is it when the second bearing was taken?
10:06.
10:06. And the first bearing is 10 o'clock. So over here, it happens at 100 hours, so 1006 hours. What are you asked to find out?
Estimate the range of the aircraft from point P.
That's it. From point P, you're asked to find out the range of the aircraft. Now, if the aircraft is moving from point A to point B, it's at different ranges to the point P. It keeps on changing. Range is basically this distance from the aircraft towards point P. Now we are kind of applying 160 here. What is this angle here? What is the bearing change? This is what is called as the bearing change. What is that?
It is 275 minus 267.
Exactly. So if you extend this, is going to be 275, and this is going to be 267, and therefore this angle is going to be 8 degrees. Right? 8 degrees.
8
And therefore
degrees.
this is also going to be 8 degrees.
8 degrees.
Right? And if you look at this particular triangle here, since this angle is relatively smaller, if I take a compass, if I keep the compass here, if I draw an arc, the arc is relatively going to be passing through it like this. It doesn't make a significant difference. And for that reason, we can actually take all these ranges throughout till from 1000 hours to 1006, all the ranges are relatively same. It is changing practically, but you can ignore that. Right? So, you are asked to estimate the range basically. So here you can look at this triangle and you can kind of apply 160 here. Why can I apply 160? Because the angle which I'm looking at is less than
8 degrees. 20 degrees.
So 160 breaks down anything beyond 20. We have seen in detail why. We see a difference between theta and z tan theta and how that is changing. Right? So this is something which you really have to be careful about. Some of the questions in NDP and stuff and relative bearing based questions, they can give you a change in bearing of more than 20, like 45 degree change in bearing. You cannot apply 160 there. If you apply 160, this arcing will not work. It's not going to be same because the distance covered is so much that it's going to be different. Say for example, if I'm moving from point P up to here and I'm estimating a point P here, this is a rough situation here. This is somewhat like that. Now think about a point here and another point here, and a bearing which is huge. Now I cannot take all these distances as same and find a common range. It won't really work. And even if I take a compass, it's going to cut all the way, and then this is not going to be the same. Therefore you cannot apply 160. So that idea should be in mind always before applying 160. You see all the glide slope and stuff, 3 degree, 4 degree, 5 degree, it's all less than 20, and that is the reason why we can apply 160 there. This is something which you have to keep in mind. Alright, don't just see that, okay, this is a similar kind of a question with 45 degree, you take tracker as 45 degree and you will get some answer, but that is not going to be the right answer. You saw why, that's why I just showed you this rough diagram here, right? You're asked to find out what is this particular range. It doesn't matter whether you find this one, you find this one, it doesn't really matter because it's all the same. Right, applying 160 to this particular triangle here, I can take this triangle as P, A, B. So, applying 160 to triangle P, A, B. Yes. How can I say that? This is the track error kind of an angle. The bearing change is always like track error, and the side opposite to that is kind of a distance off, you can say, right? So what is 160 saying? Track error is equal to distance off by distance gone.
Distance gone into 60.
So what is equivalent of track error in this particular diagram? It's 8 degrees.
8.
Right? What is distance off? That's right here. What is distance?
We need to calculate.
Distance gone. Distance gone is basically
gone. The range.
It doesn't look like distance gone in practical, but you're kind of applying the 160. That's why it is distance gone. There is no actual traveling happening here. You're kind of inducing that concept here. This is the range. That's right.
Yes.
Multiply with 60. For us to find range, the one more parameter missing is distance off. How will you find the distance off? This is the distance off. How will you find
it? We have the speed.
And?
So we have the speed that is 120 knots.
Speed is distance by time.
And we have the time.
What is speed? Speed is 120 knots.
Speed is 120 nautical into 6 minutes approximately.
6 minutes.
So 120 knots divided by 60. Divided by 60.
You have to convert minutes to degrees. Remember, for 120 knots, what is the distance traveled in 1 minute? It is 2 nautical miles. So 120 nautical mile means that in 60 minutes you will travel 120 nautical miles, which means every minute you are going to travel 2
nautical miles.
So that's a rough idea which you can keep in mind because it's going to help you in the aircraft as well. So which means in 6 minutes you will travel how much? 12 nautical miles.
12 nautical miles.
Right, so 8 degrees is equal to 12 here, so 8 degrees is equal to 12 into 60 divided by range. So find out range here. 4s are 3, 2s are 30.
60 divided by 80. 90 nautical miles.
90 nautical miles is the distance to point P. Again, I'm telling you, it's not the unique, what you call single distance. It's actually changing, but the change is so less that you can ignore it. And why is it change so less? Because the angle is less. Alright, make sense? That's it.